Alright, good morning. So I'm going to go over Factoring Chapter 3 review, or you can see this as Diagnostics, where you can try these problems and see where you're at, see if you can do them all without looking up how to do them. Okay, so there are 8 sections in our Chapter 3 that we went over, and it's polynomials and factoring and multiplying polynomials. What is a polynomial? It's kind of this right here. It's a whole bunch of different terms. Okay, this is an example of kind of a term. So there's 1, 2, 3, 4, 5 terms separated with either a minus or a plus sign. Okay, so this is a 5-term polynomial with some of them having coefficients. That's that number that goes in the front. And then the x and the y's, those are called variables. Okay, so this is a polynomial, a 5-term polynomial. Okay, so this type of question doesn't really say anything, but normally it would say simplify or make it more simpler. So when I look at this, you can only join things together if they have the exact same variables and degree of variable. What's degree? It's the little number that goes with the letter. So this is the degree. So this means that this is a x squared y. That means the x has a degree of 2. Okay, that means this variable for this term is x squared y. So it can only combine with other ones that have x squared y as well. Okay, the order doesn't matter. It could be yx squared, but that 2 has to be with that x for it to work. So if you look here, it's xy squared. The 2 in this case is with the y. The 2 in that case is with the x. Okay, so they're not the same. So you can't join those two. But if we look here, we have an x squared y over here, so we can join that one with this one because the variable and their degrees are exactly the same. Okay, the number doesn't have to be the same. So I'm going to put a little squiggly line and a little squiggly line under those two. Okay, I know I can join those two together. I look here, I have an xy, and over here I have an xy as well. Okay, so I'm going to put a straight line under those two. Okay, because I know I can join those two together. And then I'm left over with one odd one out that can't join with anything, and that's okay. Okay, one more thing to put is you note that these xy and this xy doesn't have a coefficient. So you can put a coefficient in the front, which is a 1. Okay, if there is no coefficient, it always is a 1. Okay, let's join them together. 1xy plus 1xy. How you do that is you just write the variables over again. So we'll write xy, and we add up the coefficients. 1 plus 1 is 2. There's 2 xy's. Okay. So those ones are done. Usually you can cross them off when you're done. We'll go to the next one. This one I'll just write because it doesn't add with anything, so I know that's just by itself there, xy squared. That one's done. And now last of all, we have this one where we were saying this and this is going to join. Okay, so what's negative 3 plus negative 5? Okay, negative 3 plus negative 5, you're going more negative, negative 8. And then we just write the variables again, x squared y. And that is the same polynomial, but just a different version as this 5-term one. Okay, but this one's only 3 terms, 1, 2, 3. Okay, so that's the simpler version of that same thing. Okay, now this one, this would be a question that would say expand and simplify. So expand and simplify. So if you look at this, there's kind of 3 different terms because they're separated by negatives there. But here we have these brackets, and we need to expand out the coefficient into the brackets or distribute it into the brackets for us to simplify it like we did up there. Okay, so it's kind of a step you have to do beforehand. So let's distribute the 3 into those. Okay, so we'll go 3 times x gives us 3x. 3 times 4, we have to carry that plus sign, plus 12. 3 times 4 is 12. So this whole thing is actually this. Now we're going to expand this next one, negative 3 times x, negative 3 times 3y. Okay, negative 3 times x is negative 3x. And then we go over negative 3 times 3y is negative 3 times 3 is 9 with a y. Now that all turned to this. Okay, and then last of all is this doesn't have a coefficient in the front, but you still have to distribute the negative sign, because if you remember, if there's nothing there, it's really a 1. Negative 1 times 5 and negative 1 times y. So it's going to be negative 5 and negative 5y. Okay, so I've expanded all of this. I got rid of all the brackets essentially. Now we got to do what we did at the top question. Let's look at which ones we can join. We can join this x and this x one together. So what's 3x minus 3x? Each of the symbols of operations always just are with the thing to the right of them. So negative sign is with the 3x. So it's 3x minus 3x. That just turns to 0. So we're not even going to write it. Those two are gone. Okay, now let's look at the y's. Negative 9y minus 5y. Or you can read it as negative 9y plus negative 5y. Okay, so a negative, and you add on another negative, it goes more negative. So negative 14y. Those two are gone. And last of all, we have 12 plus negative 5. Okay, or 12 minus 5, which is 7. Okay, so that one is all done, which is pretty crazy because this huge polynomial expression can be simplified just to this simple thing down here. Alright, last of all, solve. Negative 4 times 2x minus 3 equals 2x plus 11. So this type of question has an equal sign, so it's different. And that's why it says solve. Okay, because it wants you to solve for the variable. It wants you to know what that x is going to be. Okay, if you're solving, it means generally there's only going to be one variable, and there's going to be an equal sign, and your goal is to get that one variable on its own with numbers on the other side of that equation symbol. Okay, and then so your goal is to find out what x is. These last two questions, your goal was not to solve for x or y. Your goal was just to simplify the expression. There was no equal sign, and you're not saying what the y is in the end. But here, if you say solve and you see an equal sign, you can actually solve for what that x is going to be. So here we can do what we did before. There's brackets, so let's get rid of them. Okay, so we're going to distribute that 4, that negative 4, to both of those. Okay, so we are going to expand this. Negative 4 times 2x is negative 8x. Negative 4 times negative 3 is positive 12. And then we're going to write everything over again. There you go. Now it's simpler, so let's see if we can make it any simpler. Generally in this part, I'll bring all the x ones to the left-hand side and all the numbers to the right-hand side. But in this case, I want to keep my coefficient positive with my x, so I'm going to do the opposite. I'm going to add 8x to both sides, while at the same time subtracting negative 11 to both sides. Okay, those will cancel out, those will cancel out, and we'll be left over with 12 minus 11, 1, 2x plus 8x, 10x. Okay, so now we have all of the x-like terms on the right side, and we have just the numbers on the left side. So we're good to go now. We just have to solve for x. We have 10 multiplied by x. We have to get rid of that 10. So let's do the opposite of multiply. Opposite is divide. So we're going to divide by 10. And then we're left over with, those cancel out, x equals 1/10. I just flipped it around because I always like my variable on the left side. Okay, so it means when you get an equation like this, we solved and we said that for this equation to be true, x has to be 1/10, and it cannot be anything else. It has to be 1/10. Okay, so that was section 1. Then we moved on to section 2, which was looking at prime numbers. GCFs, which means greatest common factor, and LCM, which means least common multiple. These are terms that you use a lot with polynomials, especially the GCF, or the greatest common factor. So we have prime factorization, which is 3300, is the first question. Okay, so that's looking kind of at a primes. We all had to do this in our radical unit. So let's try to prime factorization this 3300. Again, primes are numbers that cannot be divided evenly by any number except for itself and 1. Okay, so we have 3300, and how you prime factors, you make a little tree. Okay, 3300, and we want to see what goes into it. I know 10 goes in to 3300, so I'm going to do that and 330. Okay, what goes into 10? I know 5 and 2 goes into 10, and I know another 10 goes into 330. All right. Anything go into 5? No, that's the lowest it goes. 2 as well. 10, we know it's a 5 and a 2 as well. And the 33 is a 3 and an 11. Okay, so I know 3300 is the same as all the branches. 5 times 5 times 2. I just like writing them beside each other, the similar ones, times 2 times 3 times 11. Okay, so that's the prime factorization of 3300. Okay, 3300 is the same as 5 times 5 times 2 times 2 times 3 times 11. Another way to write that is 5 squared times 2 squared times 3 times 11. Okay, so that's primes. Every number can be written into a unique set of primes that are different from every other number. Okay, so now we have GCF of 138 and 198 is the next question. It's saying, what's the greatest common factor of 138 and 198? And factor is another word for kind of a number that divides into it. Okay, so greatest number that divides evenly into 138, but also 198. Okay, and it's the greatest one that does that. So generally how you do these questions is you can just take your calculator and try different numbers. We know that 2 is going to go into both 138 and divide evenly into 198. Okay, that's an easy one because it's even and even. But the question is, what's the greatest one? There might be others that are greater than 2. Okay, so how do we do that? We're going to prime factor both these numbers. We're going to go 138, and we're going to prime factor that. So there's 2, and then we have 69, and what goes into 69? I know 3 will go into it, and that'll leave us with a 23. Okay, and then anything go into 23? I don't think so. So 23 is a prime, 3 is a prime, and 2 is a prime. So that has been prime factored. Let's try 198 now. We know 2 goes into there, and that'll leave us with 99. I know 33 goes into 99. 33 times 3 equals 99. And then here we know 3 times 11 will give us 33. And that gives us our primes. 2, 3, 3, and 11. Okay, so overall we have a 2 times 3 times 23. And here we have a 2 times 3 times 3 times 11. Okay, so your goal here for GCF is to see which sets share the same number. So here we got a 2 and a 3, and here we got a 2 and a 3. Those are the commonalities between the two. So since they both share those, our GCF is 2 times 3, or 6. Okay, our greatest common factor, our greatest factor is 6. So it's it's a number that divides evenly into 138 and both 198. Let's check. 138 divided by 6 is 23. Yeah, see how that's not a decimal number? That means that 6 goes evenly into it. Okay, now let's try 198. Look at that, 198 divided by 6, 33 goes into that as well. So we found out that there's no number bigger than 6 that goes into both of them. Okay, which is pretty significant. Okay, we know, for example, 138 divided by 69, that goes into evenly into 138 and is bigger than 6. But if I tried it with 198, I'd get a decimal number. So it doesn't go into both of them. Okay, but 6 is the biggest one, and we know that. Okay, so one more thing to add here is there's other questions that generally say, what's the smallest square if you have a rectangular kind of section that's 138 by 198? What's the smallest square, or not the smallest square, what's the largest square that fits inside to tile this rectangular floor? Okay, means what's the largest square that we can make so that it tiles this floor? And so this sort of thing, so it's the largest square to tile a rectangular floor, is going to be 6. Okay, so one of those tiles is going to have a side length of 6 and 6. Okay, and that's the largest square that you could tile perfectly into that rectangle. Okay, so these questions always correspond directly with GCF. Okay, now we're going to move on to LCM, and we'll notice that this one here corresponds, there's a different type of question that's to do with tiling that corresponds with LCM. What's LCM? It's least common multiple. So it's the multiple is kind of the opposite of factor. This is greatest common factor. Factor is the thing that divides evenly into something. Multiple is when you multiply your number. When you make it bigger, that's a multiple. Okay, so usually greatest common factor is smaller than your numbers, and least common multiple is bigger than your numbers. Okay, so usually how you do this is you just take your two numbers and you start writing a list about which one, or when you multiply them together. 18 times 1 is 18, 18 times 2 is 36, 18 times 3, let's take the calculator out, is 54, and I'm going to write a few different versions. Alright, so I wrote a list of 18 and the multiples of 18. Okay, 18 times 1, 18 times 2, 18 times 3, and so on. Now I'm going to do it with 30. 30, 60, this one's easier, 90, 120, 150, 180. Okay, is there any common multiples between these two lists? Okay, because these are both lists of multiples. Is there any common multiples? Let's see. Here's this right here. 90 and 90 in both. Okay. If you were to keep going, you'd find that there'd be more common multiples. There'd be bigger common multiples. Okay. But here, LCM means what's the least of the common multiples? Well, it's going to be 90. 90 is the least number that is a multiple of both these lists. Okay. So our LCM is 90. Okay. And last of all, you get these questions where it say, what's the smallest square area that you could use to tile an 18 by 30 rectangular tile? Okay, different than the last question because the tiles were square in the last one and the area was rectangular. In this one, the tiles are rectangular and the area is square. Okay, so they're saying if you have a tile that is 18 by 30, what's the smallest square that area that you can make so that your tiles fit perfectly inside that square. Okay, and the answer here is 90 by 90. It's the smallest square that you could perfectly tile with these sized tiles. Okay, which is pretty cool that you can get the answer quite quickly. So those are those two types of questions. Okay, now we're going to move on to section 3. Determine the cube root of 1728. Okay, so here we want the cube root of 1728. We're going to start by prime factorization it. Okay, so I know that 2 goes into that. And then once I do that, I'm going to go 1728 divided by 2 and hit enter. And then that'll give me the other number, 864. And I can do that again with 2. So I'm going to go divide by 2, 432. And I know that will have a 2 as well. Divide by 2. I know that will have a 2 again. Divide by 2, 108. That's going to have a 2 as well because it's even. 54. I'm going to have to go sideways now. 2. 27. And I know 27 is 3 times 9. And I know 9 is 3 times 3. So now we have branches everywhere. Okay, so I prime factored it into that. So let's write it out. 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3. Okay, so we have all this. That's the same as 1728. So it's saying what's the cube root of 1728? It means what number multiplied by itself 1, 2, 3 times will give you 1728. Is it 5? Well, 5 times 5 times 5 is 125, so no, it's not 5. Okay, so let's see what it is. So how you do this is you try to group together in 3s. Okay, those 3 2's can be grouped together. These 3 2's, the only thing is the numbers on the inside have to be exactly the same, and those 3 3's can be grouped together. Okay, so if I change those from groups of 3 just to 1, that's going to be a 2, that's going to be a 2, and that's going to be a 3. Okay, so overall 2 times 2 times 3 will end up being our cube root, which is 4 times 3 is 12. Okay, so 12 is our cube root through prime factoring. Okay, so if we go 12 times 12 times 12, we're just checking. That's 1728. Works out perfectly. Okay, so we prime factored it, grouped it into its groups of 3 that are similar, and changed them to 1. Because the cube root of 2 times 2 times 2 is 2. Cube root of 2 times 2 times 2 is 2. Cube root of 3 times 3 times 3 is 3. Alright, next one. A cube has a volume of 4,913 cubic inches. Volume is 4,913 cubic inches. That cube just goes with the unit. It doesn't have anything to do with that 4913. What is the surface area? Which means if you had to color the outside of the cube, all the walls, it means what area would you have to color it in? How much color would you need? But you wouldn't have to color the inside, right? Volume also includes the inside. So in this question, you have to just know that you have to find the 3 side lengths of this cube. Since it's a cube, all the side lengths are the same. Okay, so I'm going to write a little formula. Our volume is length times length times length, which is length cubed. Okay, if you want to find the length, you have to do the opposite of that. What's the opposite of a cube? It's a cube root. Okay, so we're going to cube root the volume to get your length. Okay, so overall our volume is 4,913. So our length is the cube root of 4,913. Okay, because it's length times length times length will give us our volume. So let's try to find out what 4,913 cube rooted is. You could do the prime factorization way to solve for that cube root, or you can take your calculator and you can go math, go down to that 3 cube root. Okay, you might actually just have a button that does that as well. And then you go 4913, and you get the cube root is 17. Okay, 17 times 17 times 17 equals 4,913. So therefore, my length using a calculator is 17, because 17 is the cube root of 4,913. And the unit will be inches, because our volume is inches cubed. So that's our side length. Okay, now it says, what is the surface area? Okay, I just found the side length. I didn't find a surface area. So how do we do that? Let's find the area of one square, okay, of just one face of that cube. Okay, what's the area? Is length squared. Is length times length. Okay, our length is 17, so it's 17 times 17. 17 squared. We can type in our calculator 17 times 17, and we get 289. So our surface area is not 289, but our surface area of one face is 289. How many faces are there? 1, 2, 3, and then there's 3 on the other side. 4, 5, 6. Okay, so surface area is equal 6 times one face. Okay, 6 times one face. 6 times 289 is 1734 inches. Okay, but the inches have to be squared. This is a little thing for it to be area. Okay, and then that one's done. All right, perfect. Thanks.